Welcome to the lecture on paired samples hypothesis testing. In this lecture, we're going to be going over paired samples. It is a hypothesis testing where we're comparing means again. And in this particular situation, we've got two different groups that we are comparing, but we're looking at the difference scores of those groups instead of the actual means of each one of those groups. So we're going to take a look at that. So in order to go through this, make sure that you read through the section in the book on matched pairs or samples, and if you click on that, it'll bring you to the section in the book. It's in chapter 10. So chapter 10, specifically 10.6, matched pairs, matched or paired samples, and it'll bring you through some examples and just give you a little bit more information about that. So next, read through this overview sheet, watch the YouTube videos. We're going through the paired samples hypothesis testing right now. And then the paired samples final project file. It'll bring you through how to do the final project portion for paired samples, and then complete the homework problems on this sheet. And then complete the paired samples hypothesis testing portion of the final project, and then submit a picture or file of the completed homework from this worksheet, and then complete the paired samples hypothesis testing quiz. Okay, so let's go through some vocabulary really quick. The only vocab really is matched pairs. Matched pairs, when you are dealing with two groups or two sets of data, two groups of data, if there's a way to match each individual observation in one group with a separate observation in a different group, those are referred to as matched pairs. And the two samples, they are dependent on each other. You might have like differences like a before and after scenario where you have like a matched pair where you take a test at the beginning of the semester and then you take another test at the end of the semester. You have two different scores, but they're matched. They're matched on the student. And so by doing that, we can actually calculate a different score for those matched pairs. We'll get into that in a little bit. So next, Cohen's d. We're still using effect sizes. This is Cohen's d effect size, so just be aware of that. Okay, so what is the purpose of this particular hypothesis test? Why would I run this hypothesis test? The main purpose of this test is to examine the mean of the difference. Examine the mean of the differences between two dependent or paired samples. More specifically, you might have a sample where you have two different scores for the exact same sample. Like, for instance, I give you an assessment at the beginning of the semester, then I give you another assessment at the end of the semester, and I compare the scores for each individual at the beginning of the semester compared to the end of the semester. Determine if there's differences between conditions. I see how well you do in performing a task when it's really cold outside, and then I give you the same task when it's really hot outside, and I want to see if there's a difference. Determine if there's differences between measurements. So like if you use credit scores, you have different credit score companies. One credit score company will rate you this way, another credit score company will rate you that way. Are there differences between the two, and are those differences consistent? And then matched pairs, there's lots of different matched pairs, and we'll go through some more examples about that. Assumptions. To be able to appropriately and accurately use the hypothesis test, what must be true about the data being tested? We've got to have one dependent variable that's measured at a continuous level. Once again, we're dealing with continuous level data. And then one independent variable that consists of two categories that are dependent on each other, that are dichotomous. There should be no significant outliers in the difference between the two related groups. There can be outliers in the actual individual groups, but when you look at the difference scores, which we'll get into that in a little bit, the first thing that you've got to do is calculate the difference scores. When you've got the difference scores, there can't be outliers in the difference scores. And then the distribution of the differences or the difference scores of the dependent variable between the two related groups should be approximately normally distributed. So we're not actually examining the two individual groups. What we're doing is we are examining the difference scores between those two groups. Okay, and then we've got the hypothesis examples, which are right here, which won't make too much sense until we actually get into it, but they are written very differently. Once again, like I said, we are comparing the difference scores, and so you'll notice that it says the mean of the differences between the paired samples. So in other words, the average difference between the paired samples equals 0 as compared to does not equal 0. The average mean of the differences between the paired samples is less than or equal to 0. The average mean of the differences between the paired samples is greater than 0. And so right now, all that we're doing is we're comparing the mean difference. The effect size, this has got to be the easiest effect size to calculate. You literally take the absolute value of the mean difference and you divide it by the standard deviation of the mean difference. Okay. So let's go through this homework problem. And I know that it says all this stuff up here. I'm going to delete this. Just follow along with this worksheet. Okay, so use the following information to answer the next 5 exercises. A study was conducted to test the efficiency of a juggling class. Before the class started, 6 subjects juggled as many balls as they could at one time. After the class, the same 6 subjects juggled as many balls as they could. The difference in the number of balls are calculated. The difference have a normal distribution. Test this at a 5% significance level. So what we need to do is we are going to, the very first thing is calculate a difference score. Well, before we even do that, let's ask a few questions. What is the dependent variable? Okay, the dependent variable, let's see here. We've got a few things to choose from. We've got before class, before versus after class, number of times juggled, and then we have 6 subjects. Okay, and so let's see here. 6 subjects juggled as many balls as they could at one time. After the class, the same 6 subjects juggled as many balls as they could. The difference in the number of balls is calculated. Okay, so here are our choices. Which one is the dependent variable and which one is the independent variable? Okay, well, I'll tell you right now, the independent variable is before and after class. Before and after class is impacting what? Is it impacting the 6 subjects or is it impacting the number of times juggled? And it is impacting the number of times the balls are juggled. So we're going to put this as the dependent. Okay, so the dependent variable. And so we've got the independent variable before and after, and then we've got the dependent variable, all of these right here, the number of balls juggled before and after class. And the 6 subjects, those are just the subjects, but we don't need to worry about those. So what do I want to know? What I want to know is, do students juggle balls more times before or after class? Okay, that's what I want to know. Before we do that, though, we've got to calculate the difference scores. Let's look at the difference scores. In order to calculate the difference scores, literally all that you have to do is take before and subtract after from before. So this right here, what is 3 minus 4? And that's going to be negative 1. Okay, what's 4 minus 5? Negative 1. 3 minus 6? Negative 3. 2 minus 4? Negative 2. 4 minus 5? Negative 1. 5 minus 7? Negative 2. Which you can see a nice pattern. And let's go ahead. I'm going to open up Excel. Control C, and I'm going to go to Excel. Okay. So we've got this in Excel now, and I'm going to go like this, equals average. Okay, and so we've got all those averages. We've got the average for after class, we've got the average for before class, and we've got the difference score. Okay, and now what we're going to do is we are going to do equals standard deviation of a sample. And I'm going to get the standard deviation. Okay, and we'll stick with that for right now. Okay. Next, so I've got the difference scores. And then let me put these means in really quick. Let's see if that works. There we go. So we've got the means. And so what do I want to know? I got that, and now we've got the null and alternative hypothesis. Before we answer this, we need to determine, is this an upper tail, lower tail, two tail? What is this? So I would say that this is an upper tail test, and the reason why is they're assuming it says the effectiveness of a juggling class. I think they're saying, hey, we think that it is going to be effective, so therefore if it's effective they should be able to juggle more. So I'm going to say that this is an upper tail. The alternative hypothesis is going to point towards the upper tail, which means that the null hypothesis is going to point towards the lower tail with an equal sign. Okay, so I've already got the signs in there, and now what is it that I'm going to be putting in there? Well, what are we comparing? What we're comparing is we're comparing the mean of the difference. Okay, the mean of the difference score. So this score right here, we're comparing this mean score. Okay, that is the main thing that we're comparing, the mean of the difference score. And I'm going to make this, there we go, the mean of the difference score. And what are we comparing it to? That is a really good question. What we're comparing it to, this may seem really odd, but we're comparing it to 0. Why are we comparing it to 0? Well, what this is saying is, if it's 0, if the mean of the difference score is 0, then there is absolutely no difference between the two groups. If the average of this score is 0, there really is no difference between the before group and the after group. And so that's why we're comparing it to 0. So the alternative hypothesis says the mean of the difference score is less than or equal to 0, while the alternative hypothesis is the mean of the difference score is greater than 0, or the mean of the difference score of the juggling before and after class is greater than 0. Okay, so what is, moving on, what is the level of significance? The level of significance, coming right back up here, tests at a 5% significance level. Okay, so I'm going to do 5%. Or 0.05, okay? And then what is the test statistic? Do we know a population standard deviation? We don't know a population standard deviation. So because we don't know a population standard deviation, we're going to go with T, okay? So test statistic is T. And then what is the calculated test statistic? So that's a really good question. A calculated test statistic, there's a few ways to do this. Okay. First of all, I'm going to Control C, and then I'm going to go paste, transpose. Okay, so I put together an Excel worksheet for you that has a whole bunch of Excel formulas. And it's basically all the Excel formulas that you need to know or that could benefit you when calculating hypothesis tests. And so one of the things that we can do is we are very much so looking for the z-value. Or sorry, the test calculated value. And so I want to know, what is the test calculated value? There's a way to get the probability of this value, but it's kind of hard to get the actual test value. And so I'm going to actually go in here. Let's see here, and I'm going to insert. Let's see, data analysis. Okay, and then I'm going to come down here, and it says a t-test for a paired two samples for means. Okay, so this is what I want, t-test for paired samples. Okay, and so I've got variable range 1. Okay, and then I've got range 2. And then I've got the hypothesized mean difference. And do I have labels? No, I don't have labels. What is the alpha? The alpha is 0.05. And then the output range, I'm going to click on output range, and I'm going to put it right here. And right away, it gives me everything that I need to answer this. This is great. So now I've got the means, I've got the variances, I've got the number of observations, I've got a Pearson correlation, which that's something we'll talk about at another time, the degrees of freedom, the t-statistic, and then the p-value for a one-tail, and the critical value. It actually has the critical value already built into there, and then the p-value for a two-tail. So let's put this off to the side, and I think hopefully we'll find it really easy to just kind of fly through this. Okay. So what is it, t? What is the calculated value? So we've got the calculated value right over here of negative 4.8107. Okay. And then what is the decision rule? Well, in order to do this decision rule, I also need the critical value. So let's just put this right here, critical value. And it's really great because it already gives us the critical value. So we're going to get the critical value right here, 2.13, 2.132 is what it is. So what we're going to do is we are going to fail to reject the null hypothesis if t calc is, let's see, this is an upper tail test. So we messed something up. By we, I mean I. In order to have an upper tail test, there's a reason why this is messed up. I said that it was an upper tail test, but when I put it into the, when I put the variables in, I should have put the one that I expected to be greater in first. Because whichever one is first, that's the one that you're testing. Okay, the way that I have it set up, it's actually a lower tail test. And so all the different scores, everything is set up to be a lower tail test. And so I've got two options, and I think what I'm going to do is I'm going to change it from before and after. I'm going to leave it as before and after, but I'm going to change it to a lower tail test. And the reason why I'm changing it to a lower tail test is because when you put the lower one first, you're actually testing the lower one, and so then the mean difference would actually be lower. And so the way that I would say this up here is it would actually say the effectiveness of a juggling class. So yes, you do want the after to be higher, but what we're actually saying is that the before is going to be lower. So the before is going to be lower, causing the difference score to be negative, or causing the difference score to be less than 0. So I'm glad that we had this opportunity to look at this and say, okay, the critical value is actually going to be a negative 2.132. The calculated value is going to be a negative 4.8107. And so we are going to fail to reject the null hypothesis if tcalc is greater than, if tcalc is greater than or equal to negative 2.132. Okay, and then the next one, reject the null hypothesis if, and we'll just copy this. Okay, if tcalc is less than less than 2.132. Okay, and so I'm going to make this a little bit bigger here, and we're going to kind of draw this in here. So is this a one tail or a two tail? This is a one tail, and we just determined it is a one tail lower tail, and we're using the t values. So t crit equals negative 2.132. Okay, and then tcalc, what is tcalc? Negative 4.8107. I'm going to make this a little wider. There we go. So we've got tcalc, and then we've got tcrit. There we go. Tcrit and tcalc. And so then we're going to put this right here, and we're going to bring this to the front. Range, bring to front. There we go. So we've got tcalc compared to tcrit, and because tcalc is beyond tcrit, we are going to reject the null hypothesis. We're going to reject the null hypothesis because anything in the green we can reject. So because tcalc, the probability of randomly getting this outcome is associated with this value, it's going to be beyond the tcrit threshold. Okay, so let's move on a little bit further, because now we need to get into the p-value, so on and so forth. So we need to formulate our decision. So our decision, we've got those two values, and so what we're going to say is, and I'm going to copy these. Because t calc of negative 4.8107 is beyond the t crit value of negative 2.132, you could say beyond or below, we reject the null hypothesis. Okay. Next, what is the p-value and what is a? Okay, so we've got the p-value. Let's go back to our Excel file where we calculated everything. And what is the p-value? Are we doing the p-value for a one-tailed test or for a two-tailed test? And the answer is we're doing it for a one-tailed test. P equals 0.00429. Okay, and then alpha, I'm going to copy this. Alpha equals 0.05. And then what we can say here is because the p-value of 0.00429 is below the alpha of 0.05, the results of this test are significant and should be interpreted further. What is our decision rule? I guess I already did that. There we go. Interpret your results in a way that you would tell your boss without using stats terms. Okay, so this is a really important part. And so what we would tell our boss is the average difference from before to after in the amount of times students are able to juggle balls is, what is the difference? So we're actually reporting the average difference score. This difference indicates that the class appears to be effective in increasing the amount of times students can juggle. The probability of this happening by chance is less than 1%. Therefore, we can be very confident that this class is the reason why students are able to juggle more times at the end of class. So that right there is the interpretation. It gives information to your boss about what they need to know. There is, the difference score is huge. That's where the result is coming from. Okay. And so we'll come back to the very last one later. So the way that I have this set up, though, just to let you guys know, we just did this one together, and then I do want you guys to do this one. Okay, but then after that, everything else is just optional for you to have practice if you want it. You don't have to do it. So just be aware of that. I only want you to do 2, and then I want you to do the hypothesis, the final project one, and that's it. I don't want you to spend too much time. I feel like, we just keep on going through the same thing over and over again, which is this process of hypothesis testing, but hopefully by the end of it, you'll be really solid with it. So that's all we got for this, and I will come back and I'll do the last one a little bit later.